Hello again. Let's take a look at acceleration of a ball in free fall. First of all, what do we mean by free fall? We mean that an object basically doesn't encounter any air resistance. We imagine the object may be very heavy and falls for a short distance where the air resistance is not a factor, or it may be an object that simply falls through a vacuum where there's no air at all. The point is, air resistance is not a factor, so the only thing affecting the falling object is the force of gravity, which we'll talk about in some detail later on. And what we have here is a ball that's falling, and as you can see, if we imagine each picture is a snapshot in which the time between one picture and the next is constant, as constant time intervals, we can see that the object must be increasing its velocity. Why? Because as you can see, it covers more distance during each time interval, and that means it must be going faster and faster to be able to cover that greater distance. In other words, it's said to be accelerating. If we take a look at this velocity versus time graph, we can imagine at t equals 0, the object is at rest. 1 second later, let's imagine the object is traveling around 10 meters per second. Another second passes, 2 seconds total, and now it's moving at a faster rate, 20 meters per second. 3 seconds pass, now it's moving 30 meters per second, and basically it's going faster and faster. Now, what I would like you to do is find the slope of this particular velocity versus time graph, and you're going to use the slope formula, which is basically the rise over the run. In this case, the rise refers to delta v. It's the change in velocity. And delta t, of course, is the time interval. So what you're to do is to pick 2 points, any 2 points along this line. Stay with the units. Keep the units attached to the particular numbers, and see if you can come up with this slope for this particular graph. So push that pause button, and then we'll come back and compare answers. Let's see what we got here. The slope value I came up with using delta v, which I can write as v final minus v initial over t final minus t initial, which can also be written as delta t. V final, in my case, was 40 meters per second, and v initial was equal to 0. In other words, I used this point here and this point right there. And I found the slope. This is my rise, and this was my run. Okay, and I kept the units, so I have 40 meters per second over 4 seconds, which gives me 10 meters per second per second. This right here tells you how the velocity is changing. In other words, it's the acceleration value for this particular falling object. And I kind of like this form, although there's another form for the units, and that is that basically acceleration is meter per second, which is meter per second squared. And that comes about because basically meter per second divided by second, I can write it like this, and that's the same thing as a meter per second. You invert and multiply, so I inverted the second, multiplied, and I got meter per second squared. So either one, meter per second or meter per second squared, is appropriate, although most textbooks and eventually I and you will be using meter per second squared. It's just easier. Although this gives you a little bit more information. It tells you basically that when every second that passes, for example, the object, when it's released from rest, initially has a 0 velocity, and after 1 second it's traveling at 10 meters per second, but it's accelerating. Every second that passes is going to gain 10 meters per second of velocity. So when the second passes, now it's up to 20 meters per second of velocity. Another second passes, a total of 3, it's gained another 10 meters per second, and now it's up to 30 meters per second. And again, another second passes, if it hasn't hit the ground yet, then it will gain another 10 meters per second for a total of 40 meters per second of velocity as it starts to fall. So this tells you how the velocity is changing with time. And basically, the acceleration is a vector and it acts straight down. always acting toward the center of the earth. All objects fall down. Even if you threw an object upwards, eventually it would fall down. And that is because the force of gravity, and thereby the acceleration caused or a result of that force, is always acting in a downward direction. So here's some important information that you should commit to memory. In fact, write it down in your supplement. One of these facts is that acceleration due to gravity is actually not equal to 10. We use 10 because it's a nice easy number to remember. It's actually equal to around 9.81 meter per second squared. And oftentimes we would just use 9.8. And sometimes we'll simply round it to 10. And this number is so special that it has a special symbol. Just like pi, 3.14, has a special symbol for that number, the acceleration due to gravity has a special symbol, and that symbol is g. Now, don't confuse this with gravity. Gravity is a force. G, in this case, is the acceleration due to gravity. Acceleration due to gravity, right? And it's a very specific value here on Earth. The other fact that you should know about acceleration, and that is that it's a vector quantity. And the acceleration due to gravity is always directed downward toward the center of the Earth, because that's the direction of force of gravity. You never see objects fall upwards. Again, you may throw them upwards, but eventually they basically will fall back down to the Earth. Let's examine our falling object a little more carefully. This object, as you can see, these numbers are changing. In fact, the spacing is increasing. It goes from 4 to 9, that's a difference of 5, and then from 9 to 16, that's a difference of 7. And basically, the reason is because this object is going faster and faster, so it's covering more and more distance per unit time. And the reason why it's going faster and faster is because it's undergoing a constant acceleration due to gravity. And this value is around 9.8 meter per second squared on Earth, and we round it oftentimes to simply 10 meter per second squared when we solve problems. But objects, when they undergo free fall motion, that is, when there's no air resistance, always undergo a constant acceleration due to gravity. Okay, so that's it for acceleration. I thank you for watching, and I hope you learned some physics.